Welcome to MA. Let us make maths easier. Today's class, question number 25. Examine the continuity of function where f is defined by f of x is equal to sin x minus cos x. Okay, if x not equal to 0, minus 1, comma, here if x is equal to 0. Okay, therefore you have to check whether the given function is continuous or discontinuous. Okay, question number 25. Here my function is f of x is equal to sin x minus cos x. Okay, if x not equal to 0, similarly minus 1 here if x is equal to 0. Okay, now we have to take cases for checking whether the function is continuous or not. Okay, case 1, x is less than 0. Okay, case 2, x is equal to 0 at point, x is here greater than 0. First here less than 0, equal to 0, greater than 0. Therefore here first of all I am taking case 1. Here less than 0 का मतलब here 0, minus 1, minus 2 up to minus infinity, you can take any value. Therefore I am taking let k be any real numbers. Okay, k be any real numbers. Okay, first here limit x tends to k, f of x, here you have to take the functions less than 0. Therefore here my function I have to take sin x minus cos x, because here it is less than 0 we can take, for greater than 0 we can take, but at point x is equal to 0, exact point, we have to take minus 1. This is my function. Okay, therefore my function f of x is here sin x minus cos x. Therefore we have to substitute the value of x here equal to k. Therefore sin k minus cos k, equation number 1. Okay, next f of a. F of a is nothing but here f of k. Therefore sin x minus cos x, in the place of x you have to substitute the k. Therefore sin k minus cos k. Okay, here it is 2. Therefore finally you have to write limit x tends to k, f of x is equal to f of a is nothing but here k. Therefore sin k minus cos k. Therefore it is continuous. It is continuous at x less than 0. Okay, case 2, here we have to take at point x is equal to 0. Therefore x is equal to a. Here a is nothing but 0. Okay, therefore limit x tends to 0 minus f of x. This is my left hand limit. Next, limit x tends to 0 plus. Here it is my right hand limit equal to f of 0. Okay, you have to, if these three values are equal, then here it is continuous. If left hand limit is not equal to right hand limit, then here it is discontinuous. Okay, let us check first left hand limit. Okay, left hand limit का मतलब here limit x tends to 0 minus f of x. Okay, first you have to take 0 minus just less than 0, minus 0.9, minus 0.8. Okay, therefore here less than 0 function is sin x minus cos x. Therefore you have to choose sin x minus cos x. In the place of x you have to substitute the value of 0. Therefore sin 0 minus cos 0. Here you have to know the trigonometry values. Okay, sin 0 0. Okay, sin 90 1. Here just reverse. Okay, cos 0 1, cos 90 0. Okay, first sin 0, here sin 0 0, cos 0 1, therefore 0 minus 1. Okay, here 0 minus 1, therefore minus 1 is my equation 1, left hand side. Okay, next right hand side, right hand limit. Okay, first limit x tends to 0 plus, because just greater than 0, 0.1, 0.2 like that. Okay, here f of x my function, therefore I have to choose the function which is greater than 0. Here greater than 0 also the same function sin x minus cos x. Therefore here you have to write sin x minus cos x. Okay, therefore in the place of x you have to substitute the 0. Therefore sin 0 minus cos 0. Okay, sin 0 0 minus 1, therefore minus 1. Here equation 2. Okay, next f of 0 at point. Okay, you have to check f of 0. F of 0 is here nothing but you have to take, this is my function for x is equal to 0, therefore minus 1. This is equation number 3. Therefore finally you have to write limit x tends to 0 minus f of x is equal to limit x tends to 0 plus f of x is equal to f of 0 equal to minus 1. Okay, here it is continuous, therefore you have to write it is continuous at x is equal to 0. At point also here it is continuous. Okay, next case 3, here you have to take x is greater than 0. Greater than 0 का मतलब here from 0, 1, 2 up to plus infinity you can take any value as your wish. Okay, next here let k be any, here it is positive real numbers. Let k be any positive real numbers. Therefore here limit x tends to k, f of x is equal to f of k. Okay, general form. Therefore you have to satisfy this. Let us check whether here it is equal or not equal. It is equal, then here it is continuous. If it is not equal, then here it is discontinuous. Okay, limit x tends to k, f of x. For greater than function, here you have to take the greater than 0. Therefore here it is my greater than 0 function. Therefore we have to take sin x minus cos x. In the place of x you have to substitute k. Therefore sin k minus cos k. Okay, next f of k. Therefore here you have to take at point. Here you have to take the same function. Similarly here we have taken now. Okay, sin x minus cos x. Here in the place of x you have to substitute k, therefore sin k minus cos k. Here limit x tends to k, f of x is equal to f of k equal to sin k minus cos k. Therefore finally here it is continuous. Here it is continuous at x is greater than 0. Therefore x is less than 0, here it is continuous. Equal to 0, here it is continuous. For greater than 0, here it is continuous. Therefore for all real numbers or real values are continuous. Okay, I hope the question number 25 is clear. If you like the video, do subscribe to our channel. Dhanyavad.